5. Let's do this. Okay, so number 1, domain. So what do you know? Take a look at number 1. What would Cookie Monster say? What would Cookie Monster say?
Can't be divided by 0.
So what can x not be? 0. 4. So we're going to say domain is x is equal to all real numbers except x cannot equal 4. Make sure you put both. Because domain is, what is the domain? Well, it's everything except 4, okay? What do we know about square roots? What do you know about square roots?
Can't be negative.
So an easy way to do this is just take the 2x plus 10 and make sure it's greater than or equal to 0. Just take what's inside and set it so that it's always positive and solve for the value of x. Well, it's negative 5, but you know, if you solve for it, you'll see it. Minus 10, minus 10. I'll have a 2x is greater than or equal to negative 10. Divide by 2, and we'll have x is greater than or equal to negative 5. And any value less than that would cause us to take the square root of it, which would be imaginary. We don't want imaginary numbers, okay? Does that seem pretty easy?
Yep.
Just take what's inside, make sure you set it greater than or equal to 0 so it stays positive, okay? 3, the problem with 3 is we really need to factor because there's going to be two values that cannot be. So x minus 4, x plus 2, right? So what we know is x cannot equal 4 and x cannot equal negative 2, but it equals everything else. So make sure you put the all real numbers in there also. Make sure you put the all real numbers because it's everything except those two, right? Everything works except those two. Okay, 4, do you need graph paper? Anybody need graph paper? Anybody need graph paper real quick, or do you have your notebooks? Everybody have graph paper? Okay, there you go, Ellie. Elise. Yep. So when I do piecewise graphs, I like to put in the boundary lines first. So I'm going to go ahead and put in my XY axis right like that, and I need to put in the boundary lines first. So put these are my boundary lines. If I get going too fast, will you tell me to slow down, please? I have a habit of going too fast sometimes. I try not to. So on the x-axis, right, at negative 7, 1, 2, 3, 4, 5, 6, 7, is a boundary line. And of course, they're invisible. They don't really even exist. And that's why I like to put them in as a dashed line. Okay, they don't really exist. They're invisible. They're just boundaries. And at negative 3, I have a boundary line. And at 2, I have a boundary line. And at 6, I have a boundary line. I have 3 graphs. I'll put the first graph in region 1, second graph in the second region, the middle region, and the third graph I'll put over here, okay? So the first graph, region 1, is really going to be y equals 3, because we know f of x and y really mean the same thing. It's a function, fx and y are the same thing. So y equals 3 is a horizontal line at 3. But I only want the between negative 7 and negative 3. So I only want this region here. And it's solid dot on both because it equals both. And I'll get rid of the rest of the line which is not included in the boundary. Am I doing okay? Mm-hmm. Okay, good. The second equation, which is y equals x squared minus 6, starts at negative 6 on the y-axis. 1, 2, 3, 4, 5, 6. Since it's an x squared, I just like the 1, 1, 2, 4, 1, 2, 3, 4, 1, 1, 2, 4, 1, 2, 3, 4, and 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Remember, Carlos, we learned how to do that? You're like, oh, I get it now, huh? He does remember it. And I'm only going to draw that parabola within the second region between -3 and 2. Open circle, but it's already closed, and this one's a closed circle because of the equal. Now, the last graph, third equation, y equals 2 minus 1/2 x. And now this is where some kids make a mistake. I'm going to show it. Don't do this. You watch him. Don't do this. We're going to start at -2, right? This is a y-intercept, isn't it? You start there, correct? Don't start there.
It's a positive, right?
It's a positive.
Okay, anyway, thank
It's
you,
a
thank you,
negative.
See, I already made a mistake. Typical me. Anyway, right, don't start here. It's a y-intercept, so start there, okay? And we're going to erase part of that, right? But we have, for the line to be in the right position, you have to start at positive 2. Not negative 2, positive 2. So then, start at 2, and I'm going to go down 1/2, down 1/2, down 1/2, okay? So it's going to look like this. I'm going to have an open circle here, right? And a closed circle here. All right? Now we got a gap. That's okay. We'll deal with it. So my domain is really from here to here, but visually it's from -7 to 6, right? So, and I like interval notation. If you like set notation, right, for the domain, right?
I think it's -6. Oh, wait, no. Oh, that's the main one.
But hold that thought, Ellie, because we're going to do it right now. Range is from -6, isn't it? Up to, well, there's a gap. It starts here. We got a tiny little gap, so it goes from up to -2, right? And then we're going to go and use this symbol. Remember that symbol, union? Remember that symbol, union? Union from -1 to 3. Okay? You all right with that? Because there's a little gap, so...
There's a value between -2 and
Oh my
-1.
goodness gracious. I'm having a day, aren't I? Never mind. We got all this here. I am having a day. Thanks. How about we go -6 to 3? Because there is graph over here. What's wrong with me? Thanks, girls. Thanks, Jose. I know you're here for me, aren't you? Okay. 5. F of 3. Don't make this hard. We got two different graphs. We've got our f of x graph and our g of x graph. The f of f got kind of hole punched, but this is your f of x, okay? Got a hole punched. So, x-axis, f of 3, 1, 2, 3. Here's f of 3. It's right there. F of 3 is right there. What's the answer? 0. It's the height. It's 0, okay? Because the corresponding y value, okay? It's just the y value, okay? F of -4. 1, 2, 3, 4. F of -4 is -2, right? G plus f of 1. So let's find g of -1 and add it to f of -1 and see what we get, okay? So g of -1 is 1. See it? Very good with that? Plus f of -1, which is 0. So the answer's got to be 1. You want me to show that again? Show it again. I want you to see it, okay? G of -1, right there, boom. F of -1, right there, boom, 0. 1 plus 0 is 1. Okay? D, graph -2 f of x. I'm just going to use a color. I know you guys don't mind the colors. Let's see. What color do I have in here that I like? Oh, here's a green. I'll do this one in green. So it's going to be upside down and twice as tall. So it's going to be, we're going to reflect over x, and we're going to change its amplitude twice as tall. So it's going to look like this. This point goes up to here. This point goes to here.
That's G of X, you're reflecting what?
I don't know what's going on with me today. Oh well.
Not enough coffee.
Must be. I don't know. Good lordy. And I'll show you what I got in a second, okay? All right, now that I know what I'm thinking, I'm glad you're here. So I took F as this graph, I flipped it upside down, and I made it twice as tall. Does that make sense? Okay.
Does it intersect at the same spot?
Yeah, because this is so easy, Carly. If the height is 0, multiply that height by 2, what do you get? If the height is 0, multiply that height by 2, what do you get?
0.
Yes. Do you see why it stays at 0?
Yeah.
Okay. All right, now, 2 of f of x is going to make it not twice as wide, but half as wide, because we need 2 curves. Half as wide, so we need 2 curves. And I'll try and use a different color for that. So everything comes in half. So this point's going to go there, there. This point at 1, 2, 3 comes into 1.5. This point comes into there. Okay, so I'll show you kind of what I've got going. Hi, Brittany. Keep your eyes on me. Make sure I don't make any dumb mistakes, okay? Oh, there's that. There's that right there. Okay, there we go. That's what I wanted. So within the width of one normal curve, I now have 2. That's why it's half as wide. And the way I did it, you guys watching? So look at the normal graph. It goes out 1, bring it into a half. It goes out, the normal one goes out to 2, bring it into 1. Just taking it in half the distance. This one intersects at 1 at 3. So I brought this point to 1.5. So you do that. It's actually, that's the easiest way to do it, is take the x values and half the x values, okay? Okay, you guys ready for 6? I'll wait for you. All right, so 6 says this. G of f of 6 says this. Put 6 there. What do you get for an answer?
1.
Take that answer 1, and put it into G. Put it right there. What do you get?
8.
Because you got 1, right? Did you get 1? Take your 1 and plug it into this equation. 2 times 1 plus 6.
Okay.
There you go. We'll do it again, because I want you to see it. Okay, so if I were to do, and I'll do it on here, so if I go f of 6 is the square root of 6 minus 5, which is 1. And I'll take g of 1, and then g of 1 is 2 times 1 plus 6, which is 8, okay? Okay, see if you guys can do the next one. See if you can do it without my help, and then we'll do it, okay? Get 16? I'll wait for you. You get 16? Thumbs up if you got 16. Jose, did you guys get 16?
No, I'll still work on it.
Okay. We're gonna have room, squish this one over here. Okay, so h of -2 goes here. It's -2 squared plus 1, which is 4 plus 1. So h of -2 is 5. Okay, now the 5 goes into the g. So g of 5 is 2 times 5 plus 6, which is 10 plus 6, or 16. Okay? Okay, try C. You got to plug it in, get an answer, plug it in, get an answer, plug it in, get an answer, okay? $16, 40? Like 40. See if we could. 40.
I got 40.
Can you get 40? I try and do them in my head, but then I'm always bound to make a mistake, right? Okay, if you got 40, anybody get 40? You guys got 40? Good. So f of 21 first is square root of 21 minus 5, which is 6, square root of 16, which is 4. Take 4 and plug it into h. So f of 4 is 4 squared plus 1, which is 17. Take 17, plug it into g. So g of 17 is 2 times 17 plus 6. 34 plus 6 is 40. Okay? Thumbs up, everybody. Awesome. Now, D. D is different because there's not a number to plug in, but we're going to take f of x, all of f of x, and plug it into h. So it's going to go right into there. Okay? So take the entire equation. Take this f of x, plug it into h. So it's going to be, it's going to be a square root of x minus 5 squared plus 1. The square and the square root will cancel each other out. X minus 5 plus 1, or x minus 4. How am I doing? Good. Okay, give me a thumbs up. Oh wait, absolutely. I warned you, I said sometimes I go too fast, don't I? And then I make mistakes, right? Okay, turn the page. All right. Okay, 7. I might need a piece of scratch paper to do it, so I'll just do it on. So first of all, graph paper. I'm going to graph x squared minus 7. Okay, that's easy. Hopefully it's easy. Oh. It's going to look like this. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Like this. Okay. This graph does not have an inverse because it fails the horizontal line test. So it does not have an inverse. So what we do is we fix the domain. So right off the bat, I'm going to say domain change. X must be greater than or equal to 0. And when I say that, then I can erase the back half of the parabola. So I do my domain change, get rid of the back half of the parabola, and then it will have an inverse. Okay, get rid of that. Now, I need the inverse. So what I'm going to do is, the easiest way is just make points. 0, -7, 1, -6, 2, -3, and 3, 2. And then my inverse would have points at -7, 0, 1, 2, 3, 4, 5, 6, 7. I'd have a point at -6, 1. I'd have a point at -3, 2. And I'd have a point at 2, 3. And I can graph in my inverse, which is a reflection of the line y equals x. Okay, y equals x. Okay, it is a reflection of the line y equals x. Now, if I want the domain of f inverse of x, it's going to be x is greater than or equal to -7. And I want the equation of f inverse of x, okay? So to get the equation of f inverse of x, I have y equals x squared minus 7. I like to write y because, instead of f of x, because I'm going to switch x and y, right? Y, f, x, same thing. And then I'm going to switch variables. X equals y squared minus 7. So I switched x and y, and now I need to solve for y, right? So, plus 7, right? Square root, plus or minus, but not really, just plus, because we already got rid of the, oh, that's a 7. I'm sorry, I get talking. How's that? There's your inverse. And I like you to write it like this. You don't have to. I wouldn't mark it wrong, but I like this symbol. I like this symbol. I like this inverse symbol. Okay? It looks better than y. How am I doing? Okay. All right. One more time. What problem do you think you're going to see tomorrow? Probably going to see this one, huh? Yeah. How many times we practice it? Enough that you'll be able to do it tomorrow, right? 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 Okay. Alex, what do you think? Yes? All right, so let's set it up, okay? Land is running north from A Street at a rate of 12. So here's 12t, 12 miles per hour, okay, 12t. And Bill is 8 miles away and is running toward east at a rate of 8 miles per hour. So Bill's a lot slower. It's just 8 minus 5t. Okay, and got a little booby. Get rid of that. That's a funny looking thing. All right. Okay. When they're closest, we'll wave at each other. Lana may not wave, you know. That boy even flipped me off once at a race.
Really?
Yeah. I've learned as a parent to say, good job, buddy, to never say, relax, you're out running right, come on, you can get him. Right?
That's my dad.
Yep. So now, the rule is, good job, buddy, you're doing great. That's it. Because you know he's running as hard as anyway, right? Pythagoras theorem, right? D squared equals A squared plus B squared. Kai, you get it then, don't you? All we want is the best for our boys, but you know, square root. When he was in 8th grade, I remember yelling at me, "Shut up, Dad!" in the middle of a race. I'm like, okay. And I'm like, but Lan, I'm a cross-country coach too, you know, I know. It doesn't matter, right? Right, Kai? It doesn't matter. Let's graph it. And how am I doing? Okay?
Can you use this?
Yes. Yes, 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 yes. So I'm going to go 12x squared plus 8 subtract 5x quantity squared. Come on. There we go. There it is right there. I'll let you get caught up. These are the points I have. Yeah.
Are we gonna graph on these for the test?
I don't see how you have I can't imagine. I mean, yeah, you're going to need to use your phone.
Yes.
Yay. Thanks, Mr. Davies.
But we have to be careful because, if I catch you doing anything else, if I catch you doing anything else with a problem like this, you will lose your phone and your test.
Oh.
Right? Right? I mean, I could do what I'm doing with my other classes. They get the first problem all by itself. They use their phone. They give you their first problem, then they give them the second test. And I can do that too, but I know there's photo math. I know that. Don't worry about it. Now, this is in terms of time. So we're going to take 0.2367 times 60, right? I don't know. I'll think about it because I could always just give you the first part, use Desmos. So we have 14.2 or 14 minutes. So it's going to be 8:14 by the time we're the closest, okay? Now the extra is the cylinder problem, okay? So we've done it. So I'm going to let you look at that if you want to get the extra credit right.